Okay, well, good morning, good afternoon, good evening. So whenever you are watching, okay, in this video we are going to solve the problems related to Pert or project evaluation and review technique. In previous video we actually discussed and then solved some problems related to CPM. So now we are going to solve related to Pert. Okay, this is actual steps. So we need to know before going to solve the problem. The first one is the draw project network, and the next one is compute expected duration, and the next compute variance, and then identify critical path, and afterwards we need to calculate the duration of completion of the project. And then at last, so if it in case in problem they are asking about the project variance or a project standard deviation means, then only we are going to calculate these two, or else we are jumping to a probability test. Under that probability test they may ask the two kinds. One is days earlier and then not more than days later can expect. These two terms they can ask. So in order to calculate this expected duration, formula is here. Expected duration is equals to time optimistic plus 4 time most likely plus time pessimistic divided by 6. This is actually a formula for calculating the expected return. And then variance is equals to time pessimistic minus time optimistic divided by 6 whole square. And the next, in order to calculate the probability z equals to ts minus te divided by standard deviation. Ts that will stands for the schedule time, and then te that will stands for the project duration. So the TS will be calculated with the help of this formula. In case it's related to earlier means T project duration minus T days. So they are already given in the problem. So we need to get that days. And then later TS time schedule is equals to project duration plus T days. It's clear. I hope that problem is a little bit complicated, but nothing to worry. If you are following the steps or procedure means it's going to become easy only. Clear? Okay, let's start the problem. Okay, this is actually a problem. In this problem they already given activity and then predecessor and then optimistic time and then most likely time and then pessimistic time, and as well as they are asking additional information. There's a draw the project network, first one, and second one is identify the critical path, and the next compute the expected duration and as well as the variance of the each activity, and then calculate the variance and standard deviation of the project. So in this problem they are asking, and at the end we need to find probability of the project if it in case 8 days earlier and as well as the 8 days later expect. Clear? So problem is actually lengthy, no worries. We can go through the step by step. Okay, what is the actual first step now? Is a draw project network. Okay, let's start. Draw the project network. In previous video we already know how to draw the project network. Here is the activity and here is the predecessor. So A is actually starting with nothing, so that's why one start with the A, done. And then next B is going to start with the A, and again C. Is there any B going to ending up with alone or together? Okay, ending up with alone. Okay, no problem. Okay, A, B, and then C. C is actually all going to derive with the A only. Next, check whether it's ending up alone or together. It's ending up with alone. So it's going to become 4. It's going to become C. Next, D. D is going to deriving from B. Again, check. Is only alone ending up in alone or together. Is actually D activity is going to ending with E. So now just draw the rough sketch. Okay, what is actually telling? So D and then E, D and then E going to ending up with together, D and then E, done. And then D deriving from B, and the next E is deriving from C. C, done. Was it clear? So now just draw the network. B is here, B is here. Now wait a minute. Yes. Okay, now it's clear. Yes. B is here, C is here, and then C is here. We need to draw D and then E. D and then E. and it will going to become 5. D and then E. Clear? Why? Because of D is deriving from B, as D is deriving from B, and the next E is deriving from C, as E is deriving from C, and the next D and then E is going to ending up together, as ending up together. So now D, C is done, D is done, E is done. Next F is actually deriving from D and then E. So D and then E. Again check whether it's an F ending up alone or together. So ending up alone, no problem. So 5 is done, it's going to become 6. It will F. And the next G is also deriving from D and E. So D and then E is deriving from deriving G. It will going to become 7. And the next H is deriving from F and then G, and then I also deriving, and afterward G deriving from G. And again observe here, H is not a predecessor for nothing, and then I is also nothing. So that's why H and then that will going to become end of the network. Clear? F is coming from, H is coming from F, and then I is coming from G. H and I activities, there is no predecessor, that's why H and I will going to become end of the problem. H from F and then G, I from G. Done. First one, draw the project network. Yes, we done. And second one is compute expected duration. Compute expected duration. In previous critical path method, they already given the duration specifically. Okay, in activity. Okay, wait a minute. Yes, in previous problem in critical path method, they directly given time estimate. It's a 5, 6, 3, 5, 7. But in this problem, they given the optimistic, most likely, and then pessimistic. That's why we need to calculate the expected duration. So that expected duration that we'll going to put here. Exactly what actually we done in the previous problem. Okay, what's the actual formula for calculating this expected duration? That is time optimistic plus 4 time most likely plus time pessimistic divided by 6. Okay, right on it. As time optimistic is 2, 4 into time most likely 4 plus time pessimistic is 6. So that means what exactly we need to do? 4 is the 4 into 4, 4 into 4, 4 into 4 is a 16. And next we need to add optimistic, it's 2. And the next we need to add pessimistic is a 6, is a 24. 24 divided by 6, we are getting 4. 4 is actually a time expected duration. Done. So I already calculated this expected duration, that is the 4. How can we get the 4? 4 is getting through the applying this formula, time optimistic 2, 4 into time most likely 4, and then time pessimistic 6, 2 plus 4 into 4 plus 6 divided by 6. So now we are getting the expected duration or time expected, it's a 4. Done. It's clear. And the next what they are asking and the problem, what's the next step? Is a compute of variance. How can we going to calculate this variance? What is the actual formula for calculating this variance? Is here. Time pessimistic minus time optimistic divided by 6 whole square. Time pessimistic minus time optimistic divided by 6 whole square. So where is that? It's here. Time pessimistic is 6 as a 6. Okay, 6, and then time optimistic is the 2. 6 minus 2 divided by 6 equals to 0.666. We need to multiply with this 0.66. That's why we need to do the square. That's a 0.66 into 0.6666. So we are getting 0.444. Clear? Am I clear? So we are just applying this formula. Time optimistic is here 4, and then multiply with the time most likely is here, and then time pessimistic is here. We just applying formula in order to find the expected duration and then variance. I'm already calculated this one. Here is the time, expected duration, and then variance. Clear? So calculation of this expected duration and variation is clear. Okay, now just apply this duration. For A, expected duration is 4, and the next B is a 6, and then C is 10, and then D 12, E 9, and then F 21, and then G 22, and then H 5, and then I 3. So done. So what is the actual next step? We draw project network. Done. Compute expected duration. S done. And then compute variance. S it's done. And the next, identify the critical path. So before going to identify the critical path, we need to do, what is that? Forward and then backward pass. So we already discussed this one in previous video while doing the critical path method. What is the actual rules? So in order to do the forward pass and then backward pass. So forward pass, that will start with the 0 plus duration, it's a 4, and then next is 4 plus 6 is 10, and then 4 plus 10 14, and the next 10 plus 12 it's 22. Again here we got that 5 getting the two activities, one is from D, one is from E. We need to take which is actually high. So 14 plus 9, it will going to become 23, and then 10 plus 12, it will going to become 22. So which is high? 23. So we need to take 14 plus 9 is a 23, 10 plus 12 is 22. So we need to take 14 plus 9, 23, because it's high. Clear? And the next 23 plus 21, it will going to become 44, and then next 23 plus 22, it will going to become 45, and then at the end that problem, 8th one, getting the two activities. One is a 44 plus 5, 49, 45 plus 3, 48, which is high, it's a 49. Forward pass is done. Next we need to do backward pass. Backward pass, we started with the same thing, starting with the 49 minus 5, it will going to become 44, and the next 49 minus 3, it's 46, and then 46 minus 22, and then 44 minus 21, which is actually low. So we need to consider which is actual low. 44 minus 21, so one is from F, another one from is G. Okay, 44 minus 21, it is a 23, and then 46 minus 22, it's 42 minus 22, it's a 24. Okay, 44 minus 21, it will going to become 23, and then 22 minus 46, it's a 24, which is low. We need to take which is actually low from the backward pass. It's 23, that's why we need to take 23. Done. And then next 23 minus 9, and then 23 minus 12. 23 minus 20, so 23 minus 12 is 11, and then next 23 minus 9, it's 14, and then now 3 and then 4 is done. We need to move to the 2. For 2, so we are getting the two activities, one is B, another one is C. So C is 6, B is 6, and then C is 10. So and then latest to finish is 11 and then 14. 11 minus 6, it will going to become 5, and then 10 minus 14, it's going to become 4, which is actually low. 4 is actually low, we need to take 4, and at the end 4 minus 4, it will going to become 0. And then how can we going to start the critical path? Critical path, there will be two rules. One is blind method, that's on earliest start and then latest start, it should be equal, and then earliest finish and then latest finish, it should be equal. Now 0 and 0, it will going to become equal. This is the first path, and then here 10 and 11 there will be a difference, and then 14 and then 14 is equal, and the next 23 and then 23 is from here, and the next 44 and then 44 is from here, and then 49 from 49, it's here. So now the activity is A plus A from C, C to E, E to F, F to H. Done. So A's activity is expected duration is 4. Okay, done. Okay, actual duration start from the A to C, C to E, E to F, F to H, and the overall the duration that specific the project is actually taking is a 49 days. Clear? So we done. What's drawing the project network, expect duration, and then we already calculate the variance, identified the critical path, and then duration for completion of the project. It's a 49 days. It's done. And the next step is compute the project variance and the standard deviation. How we can calculate the project variance and the standard deviation? Okay, first one, so just mark the duration, specific activity that actually involved. So A is involved, as done, and the next C is involved, as done, and the next E is involved, as done, and the next F is involved, as done, and the next H is involved, as done. So now adding up all the variance is first one 0.44 plus 0.44 plus 0.11 plus 2.78 plus 1 plus is equal to 4.11 is actual. So in this problem they already specifically asked calculate the variance and standard deviation of the project. Okay, variance of the project is 4.77, and the next standard deviation. How can we calculate the standard deviation? Okay, standard deviation calculate with the help of this formula. Standard deviation is equals to the sum of the variance that actually activities involved in the project, and then cancelling the root, we are going to getting the standard deviation. So we already know this one, sum of the variance involved in the activity. Sum of the variance involved in the activity is a 4.77, and then cancelling the root, we are going to getting the standard deviation. Okay, just cancel the root. So actual standard deviation is 2.18. Done. So variance of the project is 4.77, and then standard deviation of the project is 2.18. Done. So come back to the problem. Draw the project network. Yes, we already done. Identify the critical path, done. Compute expected duration and variance of each activity, done. Calculate the variance and standard deviation of the project, is done. And the next step is what is probability of the project. There will be two conditions. One is 8 days earlier, another one is 8 days later expect. Okay, so what is the formula in order to calculate the probability? Is the TS minus TE divided by standard deviation. TS that will schedule time, and then T is project duration. So there will be two kinds, early and then later. If in case early means we need to subtract the T days, what are the actual days they are given, and then later we need to add to the project duration. Done. Okay, let's start. Yes, what is the actual formula? To calculate the fourth one, probability is equals to first one. Okay, first one what they are asking, 8 days earlier. First one, it's the 8 days earlier. For 8 days earlier, probability is equals to, what's the formula? TS minus TE divided by standard deviation. TS minus TE divided by standard deviation. We don't know TS, that's why we need to calculate the TS. TS is equals to, first one we are calculating the earlier, so that's why TE minus T days. TE minus S. Okay, TS is equals to, or is the actual duration of the project minus T days. Okay, so duration of the project we already calculated. There's a 49, so 49 days, and then minus T days that will actually given in the problem. It's a 8. 49 minus 8 is a 41, and then so we need to apply to the formula. TS is a 41, and then duration of the project is a 49, and then standard deviation we already calculated. Project standard deviation is 2.18. So 41 minus 49 divided by 2.18 is minus 3.66. This is the actual probability results we are getting. So we need to find. So here we already done all the things. Probability test we are done days earlier. It's here days earlier. So now we done. At the end of the problem we need to find probability percentage. For that probability percentage we are going to use this table, standard normal distribution table. So the result is how much? It's 3.66. 3.6 is here, and then rest of the 0.6 we need to find from the horizontal line. Horizontal line 0.6 is here. Okay, wait. 3.6 it's here, and then 0.6 is here, and then the percentage is 0.00 it is here 0.0013 is the actual probability result. That means 0.0013 into 100 is equal to 0.13 or 0.13 is the actual result for the first one 8 days earlier. So now I actually done the 8 days earlier. Now we are going to move to the 8 days later expect. So second one 8 days later expect. So right, yes, 8 days later expected as usual, same formula, TS minus TE divided by standard deviation, but the calculation of the TS is a different. Later duration of the project plus T days, TE plus T days, but in the previous we just subtracted because of they are asking the earlier. So, and then expected days we already duration already calculated 49 plus, and then T days is a 8. 49 plus 8 is a 57. So now TS is a 57 minus time duration expected is a 49, and then standard deviation as usual same 2.18. So 57 minus 49 divided by 2.18 is equals to 3.66. Z equals to 3.666. Okay, same result but in a positive. So now we need to find the percentage where is actually 3.66. 3.66 is here. 3.66 is here, and then another 3.66 is here. 3.6 we got, and another 0.6, this one we need to find here 0.6, and then 3.6 is 3.6, and then 0.6 1 2 3 4 5 6 0 1 0 1 2 3 4 5 6 is here, 0.6 is here, 3.6 is here. So it is a 0.9998. Clear? So we just find it's a 3.6. Result is 3.66. So in distribution table we are getting 3.6 only, and the rest of this 0.6 is it we are going to find here 0.6 and then 3.6 we are getting 0.998, or we can say it's 99.98% probability. Okay, this is all about your Pert problem. I hope it's clear. I know it's a little bit complicated, but if you are going to remember the process and then formula, so then the Pert problem will going to be easy only. So just